So we'll start the lesson. Today we are going to cover small topics. So we are going to cover string handling, we are going to cover enumerations, we are going to cover wrapper classes, and also we are going to cover annotations. So 4 small topics we are going to cover. It won't be a lengthy session, and we will be covering few past paper questions as well. Okay, right. So first we are going to start with string handling in Java. Right. So when it comes to data types in Java, we have 2 type of data types. So what is known as primitive types and object or reference types. Right. So we have already discussed the primitive types. Those are the int, byte, short, then float and double, then boolean, char. So those are primitive types. Then under object or reference types, so there are some data types like date, string, and stuff like that, right? So what we are going to discuss today is some data types, built-in data types available to handle text or string related data. Okay, right. Right. So when it comes to strings, those are very important in any software development because we have to heavily work with string type of data like someone's name, address, email address. Those kind of things are not numbers; those are strings. Right. So when it comes to strings in Java, there are 2 type of strings. Right. So what is known as the mutable string and immutable string, right? So that is why we have different type of data types also. So the mutable strings means the strings where the the value cannot be changed in place. Immutable strings means uh, so actually that should be immutable strings. Immutable strings means the value cannot be changed. So there's a small mistake here. So that is immutable. The value cannot be changed. Whereas the mutable string means the value can be changed in place. So when I say value cannot be changed, it doesn't mean that I can't change the value, but I can't change the value in place, in the same place. Okay. So we will discuss those 2 types when we are discussing those things. So when it comes to the type called string. String is a immutable type, whereas the string buffer and string builder, those are mutable types, right? So those are mutable types. So there's a small mistake in my note. So string is a immutable type, the string buffer and string builder are mutable type. So first we are going to discuss string. Later we will be discussing the string builder and the string buffer, right? For the time being, don't take it seriously. We will discuss the difference later. But for the time being, let's discuss the string. Okay. Right. So when it comes to string, it's again a reference or object type in Java. But because it is heavily used data type, we can sometimes use it something like a primitive type. But it doesn't mean that a string is a primitive type. But because it's heavily used, we can sometimes use it some like a primitive type as well. Okay, but you have to remember that strings are objects in Java. Okay, right. So now let's see how to create a string object. So one approach is you can just create a string object like a primitive type, right? So therefore you have to say string, data type is string. Now here you can see S is capital. Usually in other primitive types, the data types are all simple like int, double, float, boolean, char. But here you can see S is capital. Uh, so the reason is in Java we follow a convention when we are naming classes. Always we start with capital letter. So since string is a class in Java, built-in class in Java, S is capital, right? So that is something you can notice by looking at that it is capital. You can guess that of course it is going to be a object type, right? So but without creating object using new keyword, because strings are heavily used, you can just create a string variable like this. So you can just say string, your variable name, then you can assign some value, or you can just declare it and you can later assign a value. So that is one way of creating string. The other way of creating string is you can just use the object oriented notation. Assuming that string is a class, you can just create object out of the string class using the constructor. So for the constructor, so it's a overloaded constructor. You can send a string literal as the parameter. Then basically these two lines are the same. Either you can create like this, or you can create like object, but most of the time the programmers prefer to create string objects like this because it's much more compact. Okay, so that is why they have allowed this, because strings are heavily used. Sometimes writing, rather than writing this long line, you can just simply write it like this. So that's only for string they have provided this opportunity, right? All the other object types you have to create objects like this, but because this is heavily used, they have provided this particular facility. Okay, right. So then again, you can create strings using char array as well, right? So either it must be a string literal, the constructor must be a string literal, or it must be a char array, right? So if you have created a char array like this, then you can send that char array to the constructor as the parameter, because it's overloaded. Either it's accept a string or it accept a char array. In both the cases, you are creating a string object. Okay, string object, right? So now let's see what are the possible operations when it comes to strings. And again, if you are creating a string, the string literals are always double quoted. You have to write it within double quotes, not single quotes. Single quotes are for the char type. Okay, right. So there are a few operations we can do. One of the most popular operation is the concatenation. To do the concatenation, you can use the plus operator. It's overloaded operator. If both are numeric, it will be addition. If if at least one is string, it is going to work like a concatenation. Concatenation means it's going to combine those two strings and create a one string. Okay, right. So there's another way of concatenating, that is the string class, because now string is a class. It has a method called concat. For that you have to send the other string, then this string will be concatenated with the other one. Okay, so there is another way of concatenation. Either you can use this plus operator, or you can use the concat method of the string class. Okay, right. So we'll do some coding rather than just going through the theory part. So I'm going to create a class called, let's say, string demo.java. So let's say public class string demo, and I'm going to have main method. Right. So let's play around with some strings. So we can create a string like this: string a equal hello. So that is one way of creating string. Another way of creating string is using the object oriented notation, that is string, let's say b equal new string. Then you have to give a string literal, like let's say, let's call this 1, let's call this 2. So that is the second way. The third, same approach, either you can use a string literal or you can send a char array. So let's first create a char array. Char, let's say c equal, let's say t h r e e. Okay, so that is a char array. So using char array also we can create a string, because the constructor accept either string literal or char array. So let's call it d, and I'm going to send the c object. So those are the three ways you can create strings. Now let's print it. System dot out dot print ln. Let's print a Similarly, let's print B and C. Right. So we are going to cover everything, B and C. Right. So let's compile and run it. So let's take command from CMD. I am moving to the D, and I am in this particular folder, and CD to that folder, and Java C. For simplicity, I am just using star.java rather than I am typing all the class names. Okay, but because that is much more convenient for me, because there are no other classes. Right, so no error means the class has been compiled. Now let's run it. Java string demo. Okay, main class. So why not main class? Public static void main string args. Why it says no main class? Okay, my I have not typed hg string demo. Right. So it's type it print 1, 2, and 3. So I created those three strings in three different way. The normal, the simple approach. Then using the object notation, I am sending a string literal first time. Second time I am sending a char array. Right. So those are the three ways you can create string objects. Okay. Right. So then the concatenation operation. So let's say I want to concatenate A and B. A and B. So it will print 1, 2 in single line. Okay, single line. Or else I can use the concat method of the string class. That means A dot, because it's a object string class has an instance where a method called concat. Concat. For that you have to send the second object, string object, as a parameter. So then B will be concatenated to A. So both have the same effect. Both have the same effect. Now let's see. So both must print 1, 2 in one line. Okay. So let's compile and see. And now you can see 1, 2, 1, 2. So those are the two ways you can concatenate. It's always handy. Go through the string class in Java API, because you can see all the methods available. You don't have to memorize each and every method. You can say string Java API. Right, so you can straight away go to the string class and see what are the methods available, right, etc. It's in Java lang package, therefore you can use strings without importing. Right, so there are so many constructors, methods. So we are going to see some of these methods. Okay, so it's always good when you are doing some software development also, you can always refer to this and see the function that you are looking for is there, then you can just use it. Okay, right. So we are not targeting the exams, so we have much more broader objectives than just passing the exam. Okay, right. Right, so that is concatenation. Then that plus equal operation is also there, because the plus operation is the work for concatenation. So I am not going to do that. Then there are some useful methods, right? When it comes to string manipulation. So if you want to find this length of a string, you have the length method, right? So if you want to find a chart, will give you which location that particular char is there, right? So you can trim. You have the two lowercase, two uppercase, index of, right? So methods like that. So I will explain few of those only. Say I have system out println. I want to find the length of a string. I can say C dot, because it's a method in string class. Now I have created a string object length. So it will give you the length of the string. For example, if it is A has the string 1, so the length must be 3. Length must be 3. So let's compile and run. It's 3. So likewise, there are some methods. So let's try out few more methods because this is a very short topic. Let's see the chart. So it will say which character is right. So let's move on. So it will say which character is at that particular index, right? For example, let's say what is the chart index 3. Now remember these are 0 base. So therefore, when I say 1, this is 0, 1, 2. So at second index we have E. Actually here you don't have the third index. So it will be, if you take second index, it will be E. It will be E. Right. So now let's see that one also. And it says C. Right. So if I go for something like 3, what will be the outcome? So you are going to get. So those things also covers in your exam. You must know what kind of error that you are going to get. Obviously, it is going to be a runtime error. Remember last time we discussed about the runtime errors and the compile time error. So it is definitely going to be a runtime error. So let's see what is the error you are going to get. Because they check whether you have tried out these things. Right, now I can see the error is string index out of bound exception. Right, so you better remember that exception name. It's a runtime error, not a checked exception. Because it's a unchecked exception. I never had to write try catch block when you are calling the child. But anyway, it's an exception. In case that exception throws, you will be getting the exception. Right now, that is why I got the exception. So it's another runtime exception that you can add to your runtime exception list. A string index out of bound exception. So some actually this some past paper questions I have seen this. They have asked whether you know that particular exception. Okay, so I will just change it to 2 because otherwise we are getting that runtime exception. So then there are some other methods. So that is given the index, see what is the character. So again we have another method. Given the character, find out what is the index. Right? What is the index? For that we have a method called index of. Right? Index of. Right? So let's use that one also. Index of. Now I will see what is the index of character n, because I am using the a variable character n. So here I have to use char if I am using the index of. If I am using last index of, I can use a string. Okay, so here it must be 1 because it's 0 base. Okay, because it's 0 base. So the best thing is you try out these things. And now it says 1. It says 1 obviously. Right. So if it is a string, usually we have to use last index of. Now let's see what will happen if you use string. Right, so for string also it works, but we have another method called last index of as well. Okay, last index of. So that will also work for string. Okay, that will also work for string. So all the things are in the note, right? So the note is available in the Google Classroom as well. I will be adding to the Google Classroom after the session because this note is not available in the Google Classroom right now. So you have the last index of as well. Okay, so both are going to work. And then you have some other methods like 2 uppercase, 2 lowercase. I am not going through each and every one. you can just experiment with those things. Okay, experiment with those things. Two lowercase, two uppercase, right? Replace all, substring, etc. Right? For example, if you want to say replace, so let's do one for replace also. So you can say a dot. So let's create a bigger string. Let's say HELLO. Right? Replace. I will say replace L with simple L with capital L. Capital L. So that is going to replace simple L with capital L. Now let's see whether it's going to replace everything, or is it going to replace only one first L or the last L, right? So now you can see both the values are replaced, right? So both the values are replaced. So all the simple L's are replaced by capital L's. Okay, capital L's. So likewise, there are some methods. Then we have substring method. So I'm just trying on few methods only. So I can say substring. So if method is all ordered, that method is if I have only one parameter, right? One parameter. So that is the starting index. That is the starting index. So that is the beginning index. So that from that index onwards to the end will be substring. Right? To the end will be substring. Right? For example, if I say here 0, 1, so here it is HE double LO. Here what will happen? So start with 1, that is the one position is this one, it will be something like this. ELLO. 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 Then if you have two parameters, it is somewhat different. If I have first parameter and second parameter, so the first parameter is the starting point, second parameter is the ending point. For example, if I say 0, 1, 2, 3, right? So you might think that because this is 0, 1, right? So let's write it. 0, 1, 2, 3, 4. So starting point is E, right? E that this is inclusive, but this one is exclusive. That means it is not going to include this cell. It is just going to say 1 to 2. When I say 1 to 3, it is going to be 1 to 2. So those are the tricky things you have to understand or remember. So the first parameter is inclusive, the second parameter is exclusive. So when I say 3, it is up to the second point. So therefore it is not ELL, it is going to print only EL. It is going to print only EL. Okay, so now let's see whether it's going to work like that. So those are the things that you have to remember because we are targeting exams as well. And now you can see it is just EL. The reason is the substring method in not only in Java in all the other languages also. For the substring method, they consider first one is inclusive, second parameter is exclusive. So when I say 3, it is up to 2. But when I say 1 here, including 1. Okay, so those are the small things you have to remember because those things are that is how it has been designed from the beginning, right? In all the other languages as well. Therefore, Java is also using the same convention. Okay, right? So that is substring. So similarly, we have the two uppercase, two lowercase. Trim method is there. Trim method will trim all the leading and trailing spaces, but it will not touch the spaces in between. Okay, you have the two lowercase, two uppercase, right? So let's do the two lowercase one also. Then we will be moving to something else. So if you want to make it all simple or all capital, say to, let's say uppercase, uppercase is so uppercase U capital C capital camel case. Okay, uppercase. So it's going to be HELLO now because it's converting it to uppercase. Okay. Now let's compile and see. Now you can see it's hello in all capital. Right. So then if you have two lowercase, it will be all simple. Okay. Right. So now let's move on. So there are a few more methods. I am not going through each and every method. I just make you familiar with those things only. Then there's a method called equals also, and equals ignore case. Right? So if you are serious doing some programming, you need all these things when you are doing coding. So again it's a instance method. For example, if you take something like this, say this is hello. I'm just taking a string, and I will say equals, let's say hello. Again it's a hello string. Right? Again it's hello string. Then it's going to say yes, right? True, because it's returning a boolean value. Now let's see whether it's going to work like that. We just checking whether the two strings are the same. Right? Two strings are the same. Right? It says true. But if I have at least one, because it is going to check the case as well. For example, if I have something like it's simple here, and now it's going to say false. So those are things that you have to remember. Now you can see it's false, right? So if you want to compare two strings without or ignoring the case, for that we have another method. For that we have another method. So that is equals ignore case. Right? So for that we have equals ignore case. Right? So then for this one it's going to say yes true, because if you ignore the case, yes, both are the same. Right? Equals ignore case. Equals ignore case C capital because it's camel case. And now it says true because we are comparing ignoring the case. Okay, right. Now let's move on. So those are the important things that you have to remember. Actually, more than understanding, you have to remember things. Okay. Then we have another method called compare to. So it will give you, if both the strings are the same, it is going to give you 0. If one string is bigger than the other one, or if the first string is bigger than the second one, it is going to give you plus 1. If the first string is lesser than the second string, it is going to give you minus 1. Okay, so when I say lesser or bigger, it will check one by one the first character. If both, now here you can see both are the same, but the second character, the second string has a lesser value a in ASCII. When I say bigger or lesser, that is ASCII table. Now b is bigger than a, so therefore it is bb is bigger than ba, therefore it says 1. Whereas in bb and bc, now c is bigger, now it is going to say, because bb is smaller, it is going to say minus 1. Okay, so that is the compare to method. It will give you 0 if both are identically the same strings with the case as well. Okay, there is another method. So I am not covering each and every method, but most of the methods I am covering. Okay. Right. So this will give you 0, 1 and -1. 0, 1 and -1. Right. Now we are moving to a very important topic, that is immutability. Right? Immutability. So that is something we have to understand more than remembering things. Okay. Immutable nature of strings. Right? So immutable nature means you can't change strings because strings are immutable. You cannot change strings in place. Of course, you can change, but you cannot change strings in place. So that is where you have to your object-oriented concepts are going to be used now, right? For example, so let's do this particular example, right? So for that, I'm going to create another class. So I'm just going to copy this class, paste. Let's call it string immutability demo dot java. Right. So I'm going to delete these things. I just need the main method. Right. Now let's see what is mean by immutability. Right. So let's take a string. Let's create a string. String. Let's say a equal hello. Okay. A equal hello. So let's do the same example in your note. So now what I am going to do is I am going to concatenate, or let's do very simple thing. Now I am going to make it two uppercase. You know how to do that? Two uppercase, right? So then I am going to print this. I am going to print A. So what my expectation is now it has to be all uppercase because we tried out that, right? So when we say two uppercase, it has to be converted to uppercase, right? So this is a very tricky thing I am going to explain. A lot of people don't understand this. Basically, they don't understand this because they don't understand object-oriented programming. Okay, right? So now let's see. Our expectation is it will be printing hello in capital because we change it to uppercase. Okay, so that is our expectation. Uh, Now let's see whether it's going to happen. So I'm compiling everything because I don't have to write each and every one. Okay, so I didn't change my class name because it's a public class. So I'm changing the class name also. Right, now let's compile. Right, now let's run it. So string immutability demo class. Now you can see what is printed is still simple hello. So our expectation was this will make it converted to capital because we are calling the two uppercase. But the reality is it has not happened. So that is what is mean by immutability in a string. Okay, that is why we say strings are immutable. Right. So our expectation is now the string object is has converted to capital hello because we do that, right? But still it is not capital hello. It is still that old hello, right? It is still that old hello. Okay, so that is something you have to understand. And that is why we have two more classes called string buffer and string builder. So a lot of people don't know why we have three classes: string builder and string buffer. So why we have string builder and string buffer is the string class behave like this. String class behave like this. That is not very good behavior in certain situations. So that is why for this kind of situations we prefer to go for string build or string buffer classes rather than string. Okay, right. So the reason is the strings behave in a very specific way, right? Very specific way. Though we call it objects, the strings are not really the objects in normal sense, right? For example, when you create a string object like this, what will happen is in the memory, the JVM have special area for strings, right? So special area for string. In that area, it will create a variable like this a, and its value will be hello. Right? Its value will be hello. Now, when we say convert it to uppercase, it is not going to change this in that place. So that is why we say strings cannot change in place. Right? It cannot. If it is changed to capital hello in place, we are not. We are going to see capital hello when you are printing, right? But the thing is, it can't do that. Normal objects, yes, that is the case, right? If you create an account, a equal new account, say a dot balance equal 100. Now the balance variable is 100. If you print a dot balance, it is going to print 100. Now if you say a dot balance equal 500, now in that memory location itself it is 500. Now if you print a dot balance, it is going to be 500. That is how the objects work. That is all about object-oriented programming. But strings are sort of a different type of objects. They are very special objects. They don't behave that particular behavior that normal object shows, right? So the reason is the JVM or the JDK has designed strings to behave somewhat differently, right? Somewhat differently. That is why we can't, or the JVM does not change it in place. Okay, in place. So if you want to get this change, you have to write something like this. That is, so this is not going to work. This is not going to work. So now I will explain you how it is going to work. If you really want to do that, say this is B. Uh, say this is B dot uppercase, and I'm going to make it B. If you do something like this, B equal B dot uppercase, now it is going to work like that. Now it is going to work like that. Now let's compile and see. Now you can see the second time when you are printing B, now it is capital hello, right? So that is the workaround actually to get around the immutable nature of the strings. Okay, immutable nature of the string. Right. Still, I didn't explain you why strings are behaving like that. Right. So the why is the most important terms in the world. Right. So that is why the people are getting crazy when someone asks why you are doing like that. Right. So the reason is when the Java people or the Sun Microsystem designed the JDK, they wanted to make sure since strings are heavily used, they wanted to make sure that strings are taking less memory. Right. The string variables start taking less memory. So in order to do that, they came up with some optimization mechanism. That is, if you have a variable say a and you have the value as hello, then in the memory this string will be represented and now a is pointing to that, right? So say this is string a equal hello. Now if you have another string b which is also hello, now what we expect is for b variable it will be allocated in different memory location because those are two variables. But the reality is now JVM is not going to create a different memory area. So it's going to say, okay, we already have the string called hello. So therefore you also look at this, right? You also look at this, right? So that is how that is to reduce the memory. That is to reduce the memory. Now now the good thing is it is going to be less memory using. It is going to use less memory. But of course, if it is a different value, like c equal by, and now it is going to have different memory because it's a different string. Right? But again, if you have d equal hello, D is also looking at this, right? So why? To reduce the memory consumption. Now when you have a code like this, B dot uppercase, right? As sorry, A dot uppercase or A dot 2 uppercase, now you can't do that in place. Why? If you change this to capital hello here, now of course now, so capital hello, LLO capital. Now of course the A dot print system, A dot, the printing of A will give you the hello in capital. But at the same time, if someone print B, that is also going to be capital hello. But we never intended to have that to happen, right? Because we just wanted only for A to be capitalized. But now if you do it in place, your B is also going to see that undesirable effect. So that is why they do not allow this to happen, right? So they do not allow this to happen because not only your variable, there can be some other variables also looking at your value. So therefore, if you change it, others are going to see it as a change which is not what is intended. So therefore, it is not allowed. So that is why we say strings are immutable. You can't change it in place. Okay. So therefore, what happens is when you execute this kind of a line, right? This kind of a line, it will create a go to a different memory location and put it as hello capital. But you are not referring to this. You are not referring to this. Still, you are referring to this old simple hello. That is why when you print system A, you still getting this simple hello, right? So of course you are creating a new string, but no one is referring to that. So therefore, anyway, it will be garbage collected later, right? So therefore, that is sort of a this line is sort of a useless line, right? But if you want to do that, you have to do something like this. Now, when you say two uppercase, it will be hello, right, in capital, and you are saying that this B must be pointing to this new one. So now your A, now earlier B is in simple hello. Now B will not be pointing to that one. B will be pointing to that one. So therefore, when you say print B, now it is going to be in capital hello. Okay. Now it is going to be in capital hello. Okay. So therefore, if you want to do some change and if you want to see that change, you have to again assign to the same variable because in place changes are not going to happen. Right? In place changes are not going to happen. Okay, right. So when you are doing the string build and string buffer, you will better understand this. Okay, you will better understand this. So why we have string build and string buffer is basically to overcome this particular issue or limitation. Right. So this limitation came because they wanted to reduce the use of memory. Okay, reduce the use of memory because strings are heavily used. Okay, right. So I hope you got the idea about why strings are called immutable. Okay, right. So I have given few more examples to understand the immutability, but I just demonstrate only one of those. Okay, one of those. Right. Now we are moving to the string buffer and string builder classes. Okay. Yeah. So why we have string buffer and string builder classes? So that is the first thing you have to understand. Of course, I can just say there are three classes: string buffer, string builder. Then you will say, okay, there are three classes. It's better to have three classes than one. But you must know why we have three classes. Ideally, I prefer to have just one class because otherwise my life is. I don't want to make my life complicated. So why they had to came up with this idea? Because string has that limitation. So string is optimized to do one thing, but there are situations we need the other thing. So for that they came up with another set of classes. Okay, right. So when it comes to string buffer and string builder, those two classes are pretty much identical classes. Right? Pretty much identical classes. Whatever you do with string buffer, you can do with string builder. Right? So all the methods are identical. So therefore, don't think that it's a headache. If you know string buffer, you know string builder. Right? So then someone will ask why we have two classes rather than one, because having two classes again headache. So again the reason is still we haven't done any thread programming, right? So thread programming is also in your syllabus. In thread programming, there is something called thread safety. One of the class is thread safe, the other one is not thread safe. Okay, so basically the string builder is not thread safe, right? Whereas string buffer is thread safe, right? So if you are interested or if you are concerned about thread safety, you have to go for string buffer. But if you are not concerned about that, you can go for the string builder, right? Again, you will understand that when you are doing thread programming only, right? So therefore, don't worry about that. For the time being, let's concentrate on one of the class, because if you can do something with string build buffer, you can do with the string build as well. Okay, string build as well. Most of the time, we will be using string builder because we don't need the thread safety most of the time. Right? String builder will work, but whatever you do with string builder, you can do with string buffer as well. Okay, right, right. So now let's see. Now let's straight away create a class. Let's call it string buffer or the string builder demo. Right, you know that there are only few people pass out in the degree, right? About 250, right? So the reason is they are not filling those gaps. They just try to concentrate and pass the semester one exams, right? Semester two exams, right? Everyone want to get their degree, right? But the reality is only 200 odd people pass out. Why? They are not filling those gaps, right? They are not filling those gaps. They just try to pass their semester one. It's not going to work. Okay, right? So let's create a class. Let's make it public class as well. Right, so let's copy the main method. Right, now I'm going to create a string builder, right? Not a string. For that, you don't have shortcut. You have to go for the object-oriented notation. String builder. Let's say a equal new string builder. Right. So for that, you can send a string literal. Right. So let's call it hello. So that is how you create string build object. So if you change it to string buffer, it still is going to work because string builder and string buffer are identical classes. Okay. Now if you want to print so something, you can just print it. It's going to behave just like the string. So it's going to print hello. But only difference is string build objects are not mutable, not immutable. They are mutable. Okay. Now let's compile this. I'm going to just compile everything so that it will also be compiled. Now let's run it. It says hello. Now let's see the this mutability, the nature of the string builder class. Okay, right. So let's for the string builder class we have different methods because it's a completely different class, right? Not the same methods are available as your string class, right? For example, we have methods like reverse, insert, delete, append, right? So append is already there, right? Right. So insert, reverse, etc. Now let's use this reverse method. Just like your string class has two uppercase, two lowercase. Now let's use the reverse method. Okay, just to explain how it's going to work. Now let's say a dot reverse. So reverse means reverse. That means the last character will be the first character will be the last character, etc. Okay. Now let's try to print this. Print a. Now it is going to print something like this. That means OLLEH. So that is what is meant by reverse. OLL. Now let's see whether it's going to happen. Now it is OLLEH. Now look at these two methods very closely. This is a dot reverse and I am printing a. It has happened. In place the change has happened. Here I did a dot to uppercase. Though the method name is different, I expected that it will be converted to capital hello, but it never happened. Right? You can see strings, they don't change their values in place. So that is why when I print a, it was still normal hello. It has never made it capital hello. But here, when I say reverse, so now it has been reversed. So why? In place, it has been changed. Right? So when I create this string buffer called a, there's a reference variable a, and it is now hello. Now when I say reverse it, it is reverse in place. O L L E H. That is why when I say now print it, it is printing O L L E H. So that is why we say string builders and string buffers can change those things in place. Whereas in string, they can't do that. They can't do that. Right. So here what happened? So that is what happened to the string buffer. So the string builder. But what happened to this say? When we say a, it is now hello. When we say to uppercase, it can't change here itself. Therefore, what happens? It was changed somewhere else. But your a is still referring to this one. So therefore, when I say print, it is still printing hello. Right? So the reason is it can't change in place, right? And no one is referring to this one, so therefore you can't get it. So that is why we have to do something like this: b to uppercase equal to b. So that is where your b is here hello. Now b is not looking at this one, it is looking at this one, but now it is in a different memory location. Now two memory locations are used. Here also memory is consumed, here also memory is consumed, right? You can see that strings are intended to intended to use less memory, right? Use less memory. But if you are going to change it, it is going to use more memory. Every time you change it, a new memory location is used. Every time you change it, another memory location is used. But if you are using a string builder, when you change, you are not going to a new memory location. In the same memory location, things are getting changed, right? So that is the difference. Okay, so now you must know why we have two things. If you have text values which once you assign, you are not going to change much, go for strings, right? So for example, if you have variable, you just assign a value and you are not going to assign new values to that particular variable, something like a constant, go for string. That is perfect, and it's also using less memory as well. But if you have a variable and you are going to do some changes to that variable itself, like you are going to convert it to uppercase, you are going to make it reverse, you are going to substring and stuff like that, go for string buffer, right? So string builder, because it's not going to consume more and more memory, it can do the changes in place. Okay, in place. So whatever you do, this string builder is going to work with the string buffer as well. Therefore I can just change this to string buffer. String buffer, still it's going to work in the same way, just like the string builder. So it's got string buffer. Yeah, still my class name is string builder. Therefore, I just have to run the same class because I didn't change the class name. It's going to give me the results. Okay, right. So that is what you have to understand. So don't memorize anything without understanding. It's not going to benefit to you. It's not going to benefit to your society. You may just get maybe if you are lucky, you will get the certificate called VIT or whatever. But you are not going to be beneficial to the society because you don't know what is happening. It's actually when you are getting more, learning more and more things, you get more and more confused, right? Because you are learning something you don't understand, right? So that is why we say understand and also ask why we have all those things. Okay, right. Now we are pretty much done with string handling, right? So now you can just go through the notes and understand. Of course, the string builder and string buffer has some other methods as well, like append method. You have the delete method where you can delete part of your string. Right? For example, you can say if this is your string, you can say delete from fourth position to the sixth position. So the fourth position means again 0. We can see that fourth position is this one, right? And the sixth position is 4, 5, 6 means this one. Remember, second parameter is exclusive, therefore it will delete 4 and 5. So here you can see 4 and 5 is not there, right? So here we are just doing it in place. We are not assigning it back to this that same variable, right? So that is why if you are going to change things frequently, go for string build or string buffer. That means you are deleting a part of it, you are inserting another part of that to that string, you are reversing, and if you are doing that kind of things, go for string builder or string buffer. Okay, right? Otherwise, if you have variable and you are not going to change that value much once you assign it, go for string. Okay, right? So we are done with that particular topic. If you have any questions, right? If you have any questions, you can ask. Okay, right? So now we are moving to the second topic. So do you have any questions on string and string build, string buffer, so that we can move to the second topic? No. Right. So let's move on to the second topic now. We'll take the past papers together because those are very short topics. Now we are going to discuss about the enumerations in Java. So that is another small topic, very small topic, enumerations. Okay. So now let's see what is meant by enumerations. So enumerations means, now remember we have different data types. Right. So now we have primitive data types, primitive. We have some object or reference types. So today we learn few of those things like string, string buffer, and string builder. Similarly, you have the date, right? And few more things we are going to discuss today under wrapper classes also, like integer, char, character, etc. Those are object types. Then the primitive types like int, double, float, boolean, etc. Right? So now we are going to discuss another type, actually another data type that we can create. Right? So this is something that if you want to create a data type, you can also create some data types with some limitations. So that is called enumerations. Right? Enumeration. Okay. So enumerations means if you want to create a variable, right? If you want to create a variable where it must have some one of the specific value, right? One of the specific value, we can go for the concept called enumerations. Okay, so it's an addition to the string data type. For example, first we have to understand why we have a concept called enumerations, right? So let's say uh, let's say we have a concept called shirt size. Shirt size. Say every shirt has a size. Right? Every shirt has a. Say we have class called shirt. Now let's do it as a coding example. So I'm just making it string handling. I'm just moving it to the. So I will be posting these classes to the WhatsApp group once the session is over, including the last session, exception handling. Right. So now let's create a class. Let's create a folder first. Say enums enumerations. Enums. Let's create the class there. Let's call it enum demo dot java. Let's call it simple enum demo, just to get an idea of why we have this concept. Right. So let's create a main public class. I will copy paste these class names. So I will copy paste. Okay, I will write the main method public static void main string. Right. Now let's see. Let's say we have concept called. So let's take some concept. Let's say we have concept called shirt. I'm going to create a class for that shirt dot java. Let's say public class shirt. Right. So let's add few variables, so the properties and behaviors. Let's only concentrate on attributes, so the properties. Let's say we have a concept called price. So add a let's go for double price. So that is fine. Now let's say we have a concept called the size. Right. For that, now we know that there are different sizes for shirts, like the small, medium, large, extra large, etc. Now, what kind of a data type you want to go? Because now we know that we have something like numeric types, boolean, char, string, and some wrapper types like string buffer, string builder. Now we have to pick one of the data type, right? So which one you want to go for? If you want to pick out of those things, can someone respond to the chat? Can someone respond to that? Which type you want to go for the shirt size? The possible values are small, medium, right? Large, extra large, etc. So you can't go for int, you can't go for boolean, right? So the naturally you have to go for string. You have to go for string, right? So let's say size, because it's going to be something like that, not the your inches or whatever, right? Something like that. But that is okay. Now let's see. Now let's get the object of the shirt class also. Here, shirt. Let's say s1 equal new shirt. So that is why we are doing this after object oriented programming. Now let's say s1 dot size. Now I can say something like large, because if any string is valid, then again I can say s1 dot price equal, let's say 1500. Now let's print that also. The size of the shirt and the price of the shirt. Right, so let's compile and run it. So I'm compiling everything. Now I am in the different folder. I'm going to move into that folder. That is the folder called enums. cd enums. I'm just compiling everything. Java star.java, Java C star.java. Right, so now everything has been compiled. Two classes has been created. Now let's try to run that class. Java shirt simple enum demo. Simple. Right. Now it says large than 1500, obviously, because we set those two properties and we are printing. Now the thing is, because the size is string type, you can assign anything. For example, you can say uh, something like hello, right? Because size is a string variable. Size is a string variable. So JDK is going to allow you any string. Any string. Now, if you compile and run it, now it's going to say hello, right? So that is not that good. So that means when you are designing a program, when you are writing programs, we want to make sure that garbage values are not going to be allowed when you are doing the programming, when you are hard coding as well as inputs. So therefore now since it is a string, any string is allowed, but we know that shared size can be, as a business rule, uh, from the domain we know that the shirt size can be medium, small, medium, large, or extra large, or maybe we may have few more things according to their business rules. Okay, but that restriction is not there. So therefore string is okay, but that is not that good. So for that kind of situation where we have to assign only one of the predefined set of values, in programming we have a concept called enumerations, right? So that will make our program more restrictive, more robust, right? So it will make less chance to assign garbage values. So that is why we have a concept called enumerations. Okay, right? Now let's see what we can do, right? What we can do. So rather than we make it string, we are going to introduce another data type, which is going to be enumeration types or enum type. Okay, right. Now I hope you get the idea of why we have a concept called enums, to make our data more specific, right? To make our data, give them less chance of getting assigned garbage values. Okay, so that is why we have a concept called enumerations. But of course you can go for enumerations when you know exactly what are the possible values, right? So if you know what all the possible values, then you can go for enumerations. Okay, like the size of a shirt or something like that. Okay, right. Now let's make it, rather than make it string, let's make it a enumerations. Okay, right. For that you can create the enumeration as a separate class, or you can create it inside the shared class as well. So that is, those are the two options. You can create the enumeration within a class, or you can create a enumeration as a standalone enumeration as well. First we are going I'm going to demonstrate you how to create an enumeration inside your class, right? So because the shirt size is something related to the shirts, it is okay to create the shirt size enumeration within the shirt class as well, because that is encapsulation, because the shirt size has the meaning only within the concept of shirt. So therefore it's perfectly okay if you create the shirt, that enumeration within the shirt class. Okay, so let's create the enumeration within the shirt class for the time being. Right, so I'm going to create that enumeration uh, in the class itself. So this is how you create the enumeration. I just make it a little bit more, something like this. Now we have created new data type, right? Just like int, float, double, which are built in, I have created a new data type called shirt size, and the possible values are small, medium, large. It can be anything that you want. So if you want, you can have go for something like extra large as well. Okay, extra large as well. Okay, right. So now rather than string, I can say the size variable must be of the type shirt size. So that is, now I am using my own type, my own data type. Okay, Right. Now you can't assign anything for size. You have to assign one of the valid size for this particular data type. So the valid sizes are small, medium and large in this particular case. If you want to introduce extra large, you can have extra large as well. Okay. Right. Now here you can't assign something like hello now. Right. So definitely you can't do that. Now let's compile. Here you are going to get the compile error now. Right, now you can see the size cannot be this, because string cannot be converted to the shirt size. Right, so the shirt you now you have to give a proper shirt size, right? Proper shirt size, not a hello or something. Right, so now what we are supposed to do is something like this. Now you have to say something like this. Mistake, shirt class has the shirt size. In that shirt size enumeration, I am picking medium. It can be medium, small or large. Right now, it must be able to run it. Now it says medium. Right now it says medium. So similarly, if I want, I can assign something like large as well, because large is a valid value in my enumeration. Right, large is a valid value, so therefore it's also going to work. Let's say Java C. But you can't assign something like this. You can't say shirt size hello. No, it's not going to work, because the shirt size enumeration has nothing called hello. Therefore, it is going to be detected at compile time now. So we want to detect as much as possible issues at compile time. Right now you can see compile time it is detected. Now remember last time we discussed that there are errors that can be detected at compile time or runtime. It is always good if you can detect errors at compile time, because then it is not going to move on to the runtime. Because if you don't detect it in the runtime by the developers or the QA people, even it can be detected at the production time. So that is really costly, right? Costly detecting errors when it is already in production. So it's always good to detect those issues at the compile time itself. Okay, right now you can't do something like that. You have to have something valid like large or small or medium. So that is the beauty of when we are using enumerations. Okay, right. So now let's see some few more concepts related to enumerations. So here I declare the enumeration inside the shirt class. That is perfectly okay, because the concept of shirt size is something related to shirts, right? So therefore it is okay, because that is what is known as encapsulation. So that concept is encapsulated into the concept called shirt, because shirt size is something to do with the shirt. Okay, right? But assume that we want to reuse this particular concept not only within shirts, maybe with some other concept as well. Okay, some other concept as well. Okay, so in that case, declaring this enumeration within the shirt class is not a very good design decision, because whenever we are referring to the shirt size, we have to say shirt size, right? Shirt size. Right? That is. So if say that is okay if you are creating shirt object, but say you are creating not shirt object, you are creating some other object, right? Some other cloth. Then if the cloth is something else, you referring to the shirt size to assign a value, that is very odd thing, right? So in that kind of situation where if you want to reuse if you want to reuse your enumeration, you can define it as a separate class, right? Separate class. So we are going to do that now. Okay. Now let's keep this shirt size as it is, because anyway shirt size is something to do with the shirt, right? So now let's introduce another concept. Now let's call it a color, right? Color, uh, right? So now color also, if I go for string, someone will say the color is 1 or the color is by. So therefore colors are, say we have predefined colors. Of course that is not a very good example, because there can be so many colors as well. Now let's try to come up with some other concept. Okay, let's say there are type of shirts. there are type of clothes, say formal, casual, or smart casual, or whatever. So that is related to the shirts, that is related to a frock, or that is related to some other cloth. So therefore, I don't want to make it inside the shirt, because that is not only related to shirt, that is something related to some other clothes as well. So therefore, I want to create that enumeration as a standalone enumeration. So everything has a reason, right? So we are not doing things for the sake of doing things. Everything has a reason. For this reason, we are doing like that. Okay, right. So now I am going to reuse that enumeration. Therefore, I don't want to make it inside the shared class. I am going to create a separate class for that. Right. So let's call it. Uh, let's call it cloth type. Cloth type.java, because I am going to reuse it for other classes as well. Right. Now this is not, though I just call it .java file, I am not going to create a class, I am going to create a enumeration. Right, enumeration. So this is how you are going to create a enumeration separately. So I am going to say enum and my enumeration name. Right, enum, it's a keyword now, new keyword enum. Let's call it cloth size. Right, cloth size. Then within the curly bracket, you have to just your shirt size, not the cloth size. Let's say cloth type, cloth type, just like the previous. So let's say casual. I'm just making it capital. It is not a must. If you want, you can just make it all simple or whatever. Let's say casual, formal, and let's have something called smart casual. Even these hyphens and those things will be allowed. So last one, you don't give a comma. Okay, right. Now I have my own enumeration. So let's compile this. Just like a Java class, you can compile it. Let's say Java C dot Java. Okay, so right. Okay, and the hyphen, it looks like the hyphens are not allowed. Yeah, it looks like hyphens are not allowed. So we'll make it smart casual. We'll see whether that is there. And it says curly bracket is also expected. We'll see. Yeah, so the hyphens are not allowed. So now I have another class. You can see cloth type class. Type class, though it's a class, it's actually related to the our new enumeration type called cloth type. Okay. Now I am going to introduce the cloth type also to my shirt, because shirt can also have the, sorry, that is not cloth type, because my shirt can be a smart casual shirt, or formal shirt, or whatever. For different shirts will have different formality. Okay. So now I am going to say not string, right? Cloth type, right? Just like our shirt size. Now we are going to say cloth type. Let's have it somewhere here, and let's say uh, type or whatever. That's variable name. Right? So now you can see my shirt has few concepts: price, size, which is of shirt size, type, which is of cloth type, right? Which is of cloth type. Okay. Right. Now when you are creating shirt objects, right? When I am creating shirt objects, just like the size, I can set the type as well. Right? Size type as well. So now I can say s1 dot type equal. Now my enumeration is not within the shirt, right? So I don't have the shirt dot. I can just say cloth type dot. Now you have to give one of the valid things only. So I will say a medium. Sorry, not medium. Cloth type. I will say a smart casual. Smart casual. Now my shirt object has a size, my shirt object has a type, my shirt object has a price, right? So now let's print the type as well. So the size is large. This particular shirt, the type is smart casual. Now let's compile and run and see. So I'm compiling everything and let's run it. Simple in Undemo. And now you can see it's a large, smart casual 1500. Right. So now it's a you can't assign anything. It must be either casual, smart casual, or formal. Here it must be medium, small, low, large. Okay. Right. So that is how enumerations work. So if you have understood this, you are done. Right. Now I am going to explain you few advanced concepts and finish this topic. Right. Enumeration. Okay. So let's get back to our note now. So I have covered all those things. And more than that, you have to understand and appreciate why we have a concept called enumeration. So that is the most important thing. Right. So we have concept called, so these are additional things, right? If you don't understand, actually you can understand these things, you don't have to memorize these things for the exam, right? Because the exam, they hardly ask any questions on enumerations. I think only maybe once in a while, maybe they ask question on that, but in the new syllabus they may ask more and more on that, okay? Because you are the first people who are going to face the new syllabus paper. Uh, so you can have, if you want, you can have concept called constructors as well, right? Constructors as well. Uh, so let's introduce a constructor and a property. This is purely additional thing I am doing, right? To the our shared class. Sorry, to our enumeration, right? To our enumeration. So I will do it for the external enumeration because that is much more easier to do that. Right. So there, if you are going to do that, you have need to have semicolon here, right? Then you have to write the rest of the code. So these are some advanced things that it's not a must for you to understand these things, but it's always good. Right. Let's assume that we have for casual, formal, and smart casual, we have some sort of a code, right? Some sort of a code, right? Simple code. Okay. And those codes we are going to take in the this particular construct. I am going to introduce construct as well for the enumeration. Okay, constructor also I wrote. Right, so this is not shirt size, this is cloth type. Right, now this is sort of advanced concept. Assume that our cloth type has a constructor also. To that constructor you can send integer. We are going to set that integer to the property called code. Right, code. Let's make it not int, let's make it string. And here we can give those strings arguments here. Right, so let's make it something like C. For this one, let's make it F. So for this one, let's make it smart casual SC or something. So now this must be string because I am sending strings. So when I say get code, it must be again string. Okay, string. Right. So now I am setting this string to this code instance variable of the close type enumeration. If you want to get what is the code is, you can call the get code method. Okay. Now let's see whether we can compile this. The close type class. Now let's compile everything. Not just the close type class. Good job. Right. So it is compiled. Now, if you set something like smart casual, its code is going to be SC, right? SC. Now you can access that one also. So after the type, let's try to access its code, because if it is smart casual, its code is going to be SC. Right? Its code is going to be SC, right? So how to get that? You have to say s1.type dot get code, because that is the method we wrote, right? So this is going to be large because we set it large. So this one is going to be smart casual, and this one is going to be for this particular case, because if it is smart casual, our constructor says smart casual code is SC. So when we say get, now SC is set to the code. Now when you say get code, we are sending this code variable, value of the code variable, which is set to the SC. Therefore it must be SC, right? SC. Right? The price will be the price you set here, that is 1500. Right, now let's compile and run it again. So let's compile everything. Let's run it. What is our class? Simple enum. Right, now it says SC. Right. So when you set, you didn't set this code. You just set the cloth type, because every cloth type has a code which you have coded in your enumeration. Now you can access the code as well. Right? So likewise you can create some, if there are some business rules like that. There are some predefined cloth types. Every cloth type has a code. You can now keep on introducing those concepts into your software, right? Using these concept of enumerations and some the concept called the constructor of the enumeration, and also now you can see the enumeration has some instance variables, instance methods as well. Okay, so that is something advanced, additional I did. But anyway, they may ask, right? Whether they ask or not, you have to understand these things if you want to appreciate and do some serious software development, right? So remember, more than half of the final year students can't do their final project, so they don't understand concept. They have just passed their exams, but we need some practically capable people. Okay, now we are done with enumerations as well. Okay, now we have covered the strings, right? Strings. We have covered the enums or enumerations. Now we are moving to third concept that we are going to discuss today. That is the wrapper classes. Okay, wrapper classes. Actually, in your syllabus, I am covering these topics. Actually, otherwise you don't know what I am covering right now. So what I have all discussed these things, right? The string class and string buffer class, right? The string constructors, length, string operations, character extractions, string comparisons, searching strings, modifying strings, right? The value of method, right? Some additional string classes like string buffer, string builder, we have done. So I have covered this part. okay, in your syllabus, right? Then I came to right. So then I came to this enumerations part. This is the part that just I completed. Enumeration fundamentals, the value of methods, Java enumerations are class types, enumeration inheriting and blah blah blah. So I did little bit more than that. Little bit more than that. Now I am going to discuss this part, that is the type wrappers and autoboxing. So that is what I am going to cover right now. Type wrappers and autoboxing, auto unboxing, etc. Okay. So afterwards, I am going to cover annotations as well. So that is our target for today, right? So I am going to first cover this part, then I'm going to cover this part. So that is what we are going to cover today. Okay, so we have covered half of it, two topics. Now we are going to cover the other two topics. Okay, so these are very small topics. So let's move on to the wrapper classes. Wrapper classes. Right. So remember, we have two type of data types now. That is the primitive types and the object or reference types, right? So the int, char, float, those are primitive types. Today we discuss some wrapper object types like string buffer, string builder. So enumeration is a special type. So that is also data types that we can create. So we discuss enums also now. Right now we can see now your toolbox is getting more and more rich. You have more and more ways of coding your software, right? So make it really robust software. Okay. Now primitive types, object or related types like string builder, string wrapper. We didn't do anything like date or stuff like that. Those things you can self study if you need, which is not part of your syllabus. Then we did the enum. Now we are going to discuss another concept called wrapper types. So wrapper types are also object or reference types, but special object or reference types, we call them wrapper types or wrapper classes. Okay. So what is mean by wrapper? You know what is the wrapping paper. So wrapping papers are used to wrap something. If you want to give a gift to someone, right? So you are not going to give it as it is. You are going to wrap it using a wrapping paper. So same thing. The wrapper classes means it is going to wrap some primitive data types. For example, if we have a primitive data type called int and we have wrapper class called integer. Wrapper class called integer. So which is wrapping this int class, int primitive data type. So we are wrapping in primitive data type, we have integer wrapper class. So likewise, for each primitive type, we have a wrapper class. And for each primitive type, we have a wrapper class. Okay, right. So now let's see first what are these wrapper classes, right? Right. So these are all the primitive types available: boolean, byte, right? Char, double, float, int, long, short, right? Those are the available primitive types, right? So you know that int, long, byte, short, those are whole numbers. Then double and float, which are decimal numbers. Then you have the boolean and char. Okay. For each of these primitive types, we have wrapper classes. Right? So it's very easy to remember. For Boolean with simple B, the wrapper class is Boolean with capital B. For byte, byte with capital B. Right? There are only two exceptional cases, char and int. Other than char and int, with the same name but capital, right? Double, double, float, float, long, long, short, short. But for char and int, we have different names. For char, the wrapper class name is character. For int, the wrapper class name is integer. Right? Other than that, For other primitive types, the wrapper class name is same as your primitive type, but the capital. Because these are classes, we know that whenever there's a class, we give the capital name. It must start with capital, sort of it's a convention. Therefore, they are following that convention. Okay. Only for Chara and Ning, they have given different names. Right? Only for Chara and Ning, they have given different names. Again, if you are really curious, right, you can see, right, you can research why Java people has decided to give different names for Chara and Ning while giving the same name for the other types. So those are for the curious people, right? So there are some curious people, there are some people who just get anything for granted, right? For the curious people, they can see, do a small research and see why Java people has decided like that, okay? Because usually, especially the Western culture, they don't do things for without any reason, okay? Right. Anyway, so now we have for each primitive type, we have wrapper types. Okay, for each primitive type, we have wrapper type. Still, I didn't tell you, right, why we have wrapper type, because the most important thing in the world is knowing why, right? So, can someone tell me why we have wrapper classes? Because if you have done some self studies, because without knowing why, learning something, we say those people are crazy people. So they must be in somewhere like Angodo, whatever, because they are doing things, they don't know why they are doing it. So those people are called crazy. Can someone tell me why we have concept called wrapper classes? Because if you don't know why we have wrapper class, you are completely in dark. You are completely in dark. So you are collecting stuff which you don't know why you are learning those things. So anyone want to give a try why we have concept called wrapper classes? Anyone? Not yet, no answer yet. Right, so the reason is in programming, sometimes we like to work with objects. Right? So when we have a variable called variable like int age, it is not object. It is a primitive value. But there are situations we like to work with objects more than primitive values because objects have some special features, right? But if your variable is a primitive type, but now that variable is not object, right? But if the particular method does something, expect an object from you, now you are in trouble. Now you are in trouble because it's your age is not a object, right? Your your salary, if it is simple, short, simply float or double, it is not object. So for that kind of a situation, they came up with these wrapper classes where you can wrap it to a corresponding wrapper class object, right? So boolean can be wrapped as a boolean. When someone is expecting boolean object, you can just convert your primitive into a wrapper class and give it because they are expecting an object, not a primitive type. If someone is expecting a long object, you can wrap it to your long primitive variable with a long wrapper class and make it long wrapper object. Then you can send it, pass it. So that is why we have wrapper classes. Okay. So that is why for each and every primitive type we are having wrapper classes. Okay. Right. Right. It's very simple concept. If you want to create wrapper classes, now you know that every primitive type has a wrapper class with the same name. Only exception is char. The wrapper class is character. For int, wrapper class is integer. Right? So that is the only exception. Other than that, the name is also the same, but they all start with capital. Right? Now let's see how to create a wrapper class. Now we'll do it as a practical example again. I'm going to create another folder called wrapper classes. Let's call it wrapper class demo. Good job. I'm just going to copy paste the method so that I don't have to write the main method and everything again. And so this is wrapper class demo. Right. So now I'm going to have something like this. Say I have a I want to create a wrapper object called integer or maybe double. So this is how we are going to do it. Say let's say float let's say a equal new float. Because it's a class, you can create object out of that. Okay. For that, the float class has overloaded some constructors. Either you can give a valid float primitive value or you can give a valid string. Right. So that is you can use something like 12.8. 12.8. So let's make it f also 12.8f because float literals are suffixed with f. Now what I have is not a float primitive variable. What I have is a float object. Right? So that is how you create a from primitive variable or from primitive value to the wrapper object. Say I want to have something like int. Corresponding one is integer. Let's say b equal new integer. Let's say 12. Or else if you had a int variable like this, int b equal 12, you could have said b also. So that is also okay. Right? So now that is how you create a wrapper object from your corresponding primitive value, literal or primitive variable. So either you can use a primitive value, literal, or you can use a primitive variable. So this is an int variable. Now I am getting an integer object, an integer object. Now let's compile this. Wrapper classes. So Java C star.java. Okay, why? B is already defined, so that there we will make it C, right? Because B is already used. You can't have two variables with the same name. We call it C. Right. Now, if you want, you can just print or whatever you want. So now you have the objects, not the primitive variables. Let's print A. It will just print 12.8 because it's just like a primitive. But what you have is a object now. What you have is object. If someone is expecting object, now I can send it. Say C. Let's compile and run it. So this will print 12.8 and this will point. So we will better understand why we need wrapper classes when we are doing the collection framework. So collection frameworks and generics are the two topics that I am going to do in the next class. There you will understand why we have wrapper classes, because for collections like list, set, map, they always expect an object. So they are not accepting primitive values. So there we need to have wrapper objects. So that is another reason why we have wrapper classes. Otherwise, you can't work with these collection frameworks, right? So everything has a reason. Here you might feel like this is overhead, but there is a reason for that, right? So it will be something like that. Let's run it also. Right. It says 12.8 and 12. It's just like primitive. But now what we are working with is wrapper class objects like a float object and integer object. Now you know how to, from primitive type, how to get the wrapper type. You can use the string as well. Right? You can use string as well. For example, you can do something like this. Say integer d equal new string as long as it is valid int value. You can give it as a string as well. Let's say 980, say 98. So this is also going to work. Let's d. Okay, right, not new string, it must be new integer. But now I am sending a string literal. As long as it is a valid int, that is fine. That is fine. Okay, that is fine. But if it is not a valid string, you are going to get a runtime exception again. Now you are encountering some runtime exceptions. Remember earlier we encountered string array index out of bound runtime exception. Now let's see what is this runtime exception. If you have something like this, let's try to have a decimal value. Now this is not a valid integer. The string is not cannot be converted to valid integer. I don't know whether it's going to truncate it. Now let's see. It's not a compiler. Now you can see it's runtime error because at runtime it can't convert this. So what is the error? Number format exception. So that is another. You in your papers also you will see these exceptions, right? So number format exception. It's another runtime error. Another runtime error. Number format exception. So let's not make it something like that. Let's make it something like valid one. Okay. Right. Right. Now you know how to convert a string to a wrapper type, how to convert the primitive to a wrapper type. So this is a primitive converted to the wrapper. This is a string converted to a wrapper. Okay. Now let's see a few more utility methods. Right. If it is a boolean, you have to create new boolean, either true or false here or true or false in string, because you can convert the primitive type or the string. Now, for other conversions mean converting from one type to another type. We have three methods here, right? So why we have make it XXX is it can be replaced with different things. So this is if I want to convert a wrapper to the primitive. So now what I did, primitive to wrapper, right? So here what I did is string to wrapper. Right? So if I want to convert wrapper to primitive, that is another possibility. Wrapper to primitive. That means I have an integer object, I want to convert it to int. Now what can we do? Right? Say now I have an integer called C, right? C, which is an integer. Now let's see whether can I get a int value. Right? Say int a b c d e equal. For that we have the integer class has a method called int value. Right, int value. So that is why we have make it name as uh, star xxx dot value, because it can be int value if you want to convert it to byte value, if you want to convert it to double value. As long as it is valid, you can do it, right? You can do it, right? For example, if you want to convert it to long variable, because int is very long as well, you can say long value, not int value, long value. That is why we name this as xxs value method. Now let's try to print those as well. And now I am printing this primitive e. It's going to be same value. C has the value of 12, so it is going to print 12. Anyway, this one is also going to be, let's make it f, same, because it's the value itself is not going to change, but different data type. This one f is also going to print as 12. Right? Now let's compile and run. So both are 12, but first one is of type int, second one is of type f. Like you have the float value, double value, etc. Okay. So once you understand, you don't have to memorize, right? You don't have to memorize. Those people who don't understand, they keep memorizing. Then they say life is hell. Right. If you want to convert string to compatible primitive type, so that is the next possibility. String to compatible or primitive. It must be compatible. Now we know how to convert string to wrapper, because this constructor supports string. That we know, string to wrapper. Now this is string to primitive. Right? Say you have this requirement. Say you have a string called string a b c d e f g equal 12.5. Now you want to assign this string value to say you have float variable h. Now you want to assign this string value to this particular variable h. So this is very widely used one, because when you get data from your UI, most of the time by default those are string. Now you can't assign it to a float, because string and float are not compatible. Now let's do it and see what is going to happen, because these are all practical problems. Now we are giving you the solution so that you can proceed with your software development. Of course, if you are not doing any software development, you don't have any of these issues. But those people who are doing software development, or at least trying to do some software development, they have all these problems in their mind, and they want to find some solutions. So that is why we are giving you this the background. Okay, now let's see. Now this is a practical scenario. I want to do this because I got it as a string, because the UI give it as a string. Now I want to get it into a float because I want to do some calculation with that. Now let's see what to do, whether it's going to work. Right? No. Why? These are not compatible. So this is a string variable you are trying to assign to a float. Right? So that is where string to primitive conversion is needed. For that, we have a way with the help of the wrapper classes. Right? With the help of the wrapper classes. So each wrapper class has, right? Each wrapper class has, again we are calling pass xxx, because it can be pass int, pass float, pass double, etc. Right? Now let's do that. Right? So I want to convert it to float, therefore I want to use a float wrapper class dot pass. I want to convert it to uh, I want to convert it to uh, float. Therefore, it is going to be pass float. Pass float. Now I can send this string. I can send this string. And now it is I am going to have a float variable having this value which is earlier string. Now it is now h is going to have 12.5. Now let's print it and see. So without this there is no way to do this. Now I want to print this. It is going to be 12.5, and now it is a primitive variable h I am printing. So h. Now let's run it. Now it is 12.5. That is a primitive variable. Now you know how to convert string to primitive, right? If you want to convert it to int, and if it is a valid int, you have the integer class has a method called pass int. Right? So that is why we say pass xxs. Each class has a method with its own class, right? For example, the short class has a method called pass short, right? So that is how you do it. Okay. Of course, it has to be valid value, otherwise you are going to get that number format exception, which is very famous runtime exception. Okay, right. Again, if you want to convert string to a compatible wrapper type, already we have one approach, that is your constructor is accepting strings, right? Constructor is accepting string. But we have another approach as well to convert. So let's call it approach one. So we have another approach to do that, string to wrapper conversion. Then we are done with this topic as well. That is, now assume that I have string ghi, let's call it 13.8 as a string. Of course, I can create, like if I want to convert it to float or something, float f equal new float within the with the parameter you can give it. Let's look at the second approach. So you have a method called value of. Each class has a method called value of. So that also we can use as a second approach. For example, if I want to convert this to a float, ij, I have float class has a method. Now you can see that if I write like a method like this with the class name and method, you know that that is a static method. Right? So those things we discuss on the object oriented. If you are writing a method like this, class name and the method, that means it's a static method in that class. But these are instance methods. These are reference variable and method, right? But these are some class methods. Right? Class methods. So let's send I to here because I is a string. So now you are going to get the float object. So string to wrapper, this is the second approach. Second approach. Okay. If your object has already been created, now you have used this approach. If the object is now you are creating, you could have gone for this particular approach as well. Here you can have gone float and float. Okay. Right. Now let's see whether it's also going to work. J. It must be 13.8. Float. Now it's a float object. Now if you want to convert from float object to the float primitive, you know that also, right? Wrapper primitive. Or if you want to directly convert from string to the primitive, yeah, you would have also float dot pass float. Here it's a float dot value of. So likewise, there are so many. All the possibilities are covered. Whatever the requirement, you have a way. Right, 13.8. Okay. So that is all about wrapper classes. So you must know what are the wrapper classes, why we have a concept called wrapper classes. Then you must know how to convert between primitive to wrapper, string to wrapper, wrapper to primitive, right? The string to primitive, etc. Okay, so different ways. So yeah, we are done with that. Now we are going to discuss very small topic related to wrapper classes, that is autoboxing. Right? Autoboxing and auto unboxing. Right now already you may have seen that this conversion is a real headache. You have to remember this method. Now if I have a primitive value, right, primitive value uh, like 12.8f, I have to create this as an object. Right? Again, if you have a wrapper, you have to convert using these int value with those methods, right? So you have to remember these methods, which is little bit overhead. So therefore later they decided, let's make it automatic. So that is why we call it auto boxing. So let's make if you have a valid primitive int, you can straight away assign it to integer. If you have a valid integer, you can straight away assign it to a int. If you have a valid float object, you can straight away assign it to a float primitive variable. If you have a valid float primitive variable, you can straight away assign it to a float object. Right? So that is called auto boxing and auto unboxing. Right? So that is to make your life much more easier. Right? So now let's do this. Say I have a float variable primitive. K equal 12.7f. Now I have a float object, float L. Now I don't, if you want, you can convert from float to capital primitive to the wrapper by creating object, right? But that is not a must. That is not a must. You can simply say this is K. Right? That is K. Right? That is called auto boxing. And that is called auto boxing. You can simply assign values like that. Okay. Okay, let's do it other way around. Say I have float. I have float k equal new float right, something like this 12.7. Right now, if I have float variable L, now you can simply assign like this. So that is called autoboxing. Right? Without conversion from proper to the primitive, this way, using the int value, long value, or the float value, now you can simply assign like this. So that is called autoboxing. Right? So the earlier approach was what? K dot float value. This approach says no, you can simply assign it. Simply assign it. Now let's print and see. Let's print L, and it must print 12.7. That is to make your life much more easier. Right? No compile errors, and it says 12.7. Right? So now you can see when you have float object, you can straight away assign because it is auto box, right? Auto box to the compatible type. Compatible type. Okay. Now let's see whether we can do it other way around also. Say we have a variable, let's say int m equal 16. Now let's see whether we can do it for the integer. Of course, first we have to create the object n equal new integer because it's object type. Now you can at different times you can assign values to this one. N equal, I can say m. Right? So M. Right? So you can do that. Now this is primitive type. This is wrapper type. You are just assigning because now it is auto unboxing. Now it is auto unboxing. Now let's see whether it's going to work. I'm going to print n now. It must be 16. So first we have to compile. Okay. New integer. Okay, so you need some value here. Right? Say, assume that earlier it was having some other value like 15. Right? Now I am going to assign it to. Now of course it is going to be 15 at that point. At that point, it is going to be 15. But now n is an integer object. M is a primitive int. I can just assign it. Auto unboxing will occur, and now it is going to print 16. Okay, because when you are creating integer you must give some value initially. Right, now let's compile and see. Right. Earlier it is 15, now 16 is a primitive value that we straight away assign. Right. This M has a 16 primitive value, we just straight assign it to the wrapper class. That means we can do something like this also. Now remember n is an integer object, but I can assign something like this. N equals 76. So I can do that. Though n is an integer object, I can now start assigning like that because this 78 in literally is going to be auto unboxed into a 78 object. Right? So now it is going to be 78. So that is called auto boxing and auto unboxing. Okay. $78. Right. Now we are done with wrapper classes as well. Right. So we are done with wrapper classes. And now we are moving to the final topic that we are going to do today. That is very small topic. That is annotations. Right. So far we have discussed enumerations, wrapper classes. What is the other one we discuss? String handling. Now the final topic, annotations. Right. Annotations. So annotations are also mentioned in your syllabus. So we are going to cover that. Okay, we are going to cover that. Right. Now let's see what is meant by annotation and why we have concept called annotations. Okay. So the most important thing is why we have a concept called annotation. So this is something you may not fully understand at this point, or you may not fully appreciate. You may not feel the real use of annotations right now. But when you go into your final year, when you are doing some advanced programming like middleware architecture, web service development, etc., and also when you are doing a final year project, if you are using a concept like Java Persistence API, Hibernate to connect with databases, you are heavily going to use annotations. So annotation is part and parcel of your life. Okay, for advanced programming, that is where you are going to appreciate those concepts. Right now you are just going to learn the theory part. You may not fully understand why we have annotations, but you are going to understand, and you are going to heavily use these concepts when you are in, especially when you are in the final year. Okay, right. So let's see what is mean by annotation. So annotation is a tag that represent a metadata. So metadata means data about data, some additional information about that data. If you want to give some additional information about that data to the program or the compiler, you can use the concept called annotations. Okay, so you may not fully understand it right now, but you will start using those concepts when you are in the next years. Okay, right. So anyway, let's try to understand a little bit of what is meant by annotations. So there are some built-in Java annotations, right? The override, suppress warning, depreciated. So those are some built-in annotations. Okay. Then of course we can create our own annotations as well. Okay. Now let's do some sort of let's use few of those already the built-in annotations. Say, so I'm going to create another folder, annotations, and just going to copy one of the class here so that I don't have to write much. So here we are not going to run and see things because annotations are used by some other advanced concepts. And here I'm just going to introduce the concept only, concept called annotation. So actually I don't need a main method as well. Let's say I have method. Let's create another class, new Java class. Let's call it my class dot Java. So I never tell anything without practically demonstrating, right? So that is what you need, right? Otherwise, this become another theory part, right? So let's say public class. So you must also do the same thing. Don't go to the bed and start learning Java. That means you are really crazy. After sometimes you are going to be a nutcase, right? So not a right. So you will ended up in somewhere in mental hospital if you start learning programming using books and other things. Okay, right? Public class. Let's say my class. Right. So let's have method. Say public void. Let's call it my method. See, you are just printing something. Say hello. Right. So this is just a simple class. So I'm going to create this object there. Right. So then I can call this method my method. Let's make it simple then without breaking the conventions. Right. So that is a very straight away thing. So let's move to that folder. CD, come one step above, then go to annotations. That is my folder. I'm going to compile everything. Java C star.java. Okay, public void my method. Okay, so if there are no parameters, still we need to have the brackets. System spelling mistake. And now let's try to run annotations demo. You can just type few characters and use your tab. It will give complete your file name. We just say hello. Right? Just say hello because this method just say hello and I just call this method. Now I will just explain one of the usage of annotation. Now assume that this class has been there for some time. In the future, I am not going to use support this method in the future. Right, in that case, I can Java has a built-in annotation called depreciated. Depreciated. So you can just put that annotation there. Depreciated. Depreciated. Right. So that is to tell your users that I am not going to use this, or I am going to get rid of this method in the future. Maybe not immediately, therefore better not to use this. So you can see this is a meta information. I am giving some more information about this method to the this is, in this case, this is for the software developers. Don't use this method unless you are really needy, right? Because I may be discontinue this support for this particular method. So that is what the depreciated or deprecated annotation is all about. It's a built-in annotation. So when you are compiling, it won't give any message. Of course, it gives a small warning, right? So it says that annotations Java uses overrides use or override a depreciated API. So that means since I have given that annotation in my class, if someone is using it, right, if someone is using it, now remember this is annotations demo Java, right? Annotations demo Java. So that is this class is using this method, and when I compile this, my compiler give me a warning saying that be aware you are using a method which is going to be which is already depreciated. You better not to use it. But of course you can use it. That is why it is not forcing me to remove it, but it is giving me the warning, right? So that warning the compiler can give why I have given that meta information in my method, right? Meta information in my method saying deprecated. Okay, deprecated. So likewise, already there are some deprecated methods in Java JDK also. So in that kind of situation, if you are using those things, we will get this warning. Then we can decide whether we are going to use it or are we going to use some alternative method, because we want some long-term maintenance of our software. Okay, say that there's a deprecated method you are using, say current JDK, maybe in 3 years time in the new JDK that method is no longer there, then your program is not going to run in your new JDK. When you upgrade to the new Java version, your software is not going to work. So that is why rather than they all of a sudden remove those methods, they just mark it as a deprecated for some time, then only they are going to remove it. Right? Then only they are going to remove it. So that is one of the use of annotation. That is just one of the use. Okay, there are so many annotations with various usages. Okay, various usages. Uh, so, for example, we have mentioned few things. If you are overriding a method of a subclass, superclass, you if you want, you can just have this annotation saying override. Then someone who is reading your class has a very good idea. Okay, this is overridden method. So otherwise, he don't have any idea unless he has seen the superclass, right? But when you have this override annotation, it's a very good information for the that your fellow programmer, he knows that this has been overridden from superclass. So likewise, there are some built-in annotations that you can use for really good purposes. Okay, and of course you can create. So now you can see this is the animal class, has something method called eat something. In the dog class, we are overriding the eat something same method. Now it's always a good practice to have this ampersand override or the having this override annotation, so that your fellow programmers knows that this method is in the superclass as well. So that is good information for your fellow programmer, not only your fellow programmer, even for you, because you may be doing bug fixing of this particular class after sometimes even you have forgotten that. But when you see this override annotation, you know that yes, it has been overridden. Okay. So likewise, there are different meanings, different usages, right? So, okay, right. So if you want to create your own annotations, right, your own annotations, you can create your own annotations as well. Only thing is you have to just create something like a class but you have to say it's a ampersand interface and new annotation name, right? So let's create our own annotation. So let's say my annotation dot java. Now so far you have been working with either classes or interfaces. So today we create another type called enums. Now we are creating another type called annotations, right? Other than the classes. Right. So my annotation Java. Why it is not right? My annotation. So this is how you create it. Ampersand and your annotation name. Right? Annotation name. Sorry, interface and your annotation name. Not just interface, ampersand interface, and you can give your annotation name my annotation, and you can just have two things because we are not introducing any parameters or whatever right now. Okay, right. So this is annotation. Right. So now let's compile this, because when I compile everything, this will also get compiled. So that depreciation warning is there, deprecation warning. That's let's forget about. But you can see that my annotation class has been created. Right? For this particular my annotation, the my annotation class has been created. Now I can use this one also as another annotation. Right? For example, in my this class, not only deprecated, I can say my annotation. Of course, it doesn't have any meaning right now. You can do it meaning when you are doing some advanced software development, right? So now let's see whether we can compile it, because everything we are going to compile now. Now it's getting compiled, right? So you can't have whatever you like, right? For example, you can't say my say your annotation or whatever, because there is no annotation called your annotation, right? So there is no annotation called your annotation in Java JDK. There is no annotation called your annotation you have created. So therefore, definitely now you are going to get a compiler. Right? You can say they can't find what is meant by your annotation, right? So it must be a valid annotation. Then only you can use ampersand and your annotation name, right? So it must be a valid one, right? So my annotation is a valid one because I just created my annotation and I have compiled it, right? I have compiled it. Of course, still it is not having any meaning. You can have your own meanings. Those things we will be discussing when you are in your especially when you are in the final year. Okay, right. So again, for the annotations, you can have parameters as well, right? Some parameters as well. uh, right? So something like this, if you want, you can have multiple parameters as well. So let's straight away create a give it some multiple parameters. Right, so now I have introduced three parameters to this annotation, called my annotation. First one is a int, second one is a string, third one is also string. So the values are called value 1, value 2 and value 3. Now when you are using the annotation, you have to provide those values, otherwise you are going to get compilers. Right? Now let's see whether we can compile it. I am going to get error. Right, now it says uh, is missing default values for value 1, value 2, value 3, because this my annotation has need expecting three parameters, right? But you are not providing it. So if you are not providing, you are going to it's not going to work. Now I have to provide these values in string. Now let's give some values. you have to say give same name with this equal mark. So you have to say value 1, it is expecting an int, let's say 5, value 2, it is expecting a string, let's say hello, value 3, it's again expecting a string, let's say bye, just a string, right, value 3. Now it's going to compile, right, because value 1, value 2, value 3, int, string, string, right. So my annotation expect int, string, string in that order. Now let's see whether we can compile it. Now we should be able to compile it, right. So these are just the warnings, right. Again, the data type must also be the same, right. For example, here you can't do something like this one because it is expecting an int. Now you are giving a string, right, because it is expecting an int for the first one. You are giving a string. Now I am going to get error again, right. So it says something wrong here. So you can see if the annotation expects some parameters, you have to give the exact data type as well, right. And of course, if you want, you can have default values so that if the user do not send, you can have it, right. For example, let's give it a default value. If you have default values, you can just say default and the value, right? Default and the value. Let's say I am going to give a default value to this one. Default, let's say high. So the default value is high for value 2. Therefore, giving value 2 is optional now. Right? Giving value 2 is optional now, but you have to give value 1 and value 3. Right? Value 1 and value 3. Now let's see whether it's going to work. Now I'm going to remove this value 2 because value 2 has a default value as well. Okay. Now let's see whether it's going to work. And now you can see no compilers. No compilers. Earlier there was compiler because now it has a default value. If you don't send value 2, it is going to get it as high. But still you can't skip these things. Right? Skip these things. Of course, if you have those also have default values, even you can skip all those things because then the default values will be taken. Okay, so we are done with the annotations. Right? We are done with that. Anyway, I will just show you one use of annotations in your final year in web services. So you have something called middleware architecture. There you have the web services. There we will be heavily using annotations. When we are creating web services, we have to say that we are going to expose it as a web service. We are going to expose it as a or especially when you are going with database programming, there also we have to say, okay, this is mapped to this particular table, this class is mapped to this particular table, this field is mapped to this particular column. So those things are meta information. We can use annotations, right? You can see here, right? You can see here path annotation, get, proceed, right? Producers, all are we are heavily using annotation. So that is how we are mapping our web service to the different other concepts. So heavily we are using annotations everywhere, right? So if you don't understand these things here, you are not going to do your final year, right? So then your life is going to be miserable. So don't expect to go to the final year and learn annotations. You go to the final year and learn your web services, not annotations, right? Because otherwise you are going to be exhausted, right? So learn your annotations now, right? Learn your annotations now, right? Don't just pass your semester fun. Have your background, okay? Have your background, right? So we are done with that, right? We are done with annotations as well. Now let's take the past papers and do maybe just few past paper questions, okay? Right, and stop it, finish it. So we are not going to spend more than 10 minutes anymore because these topics they have hardly asked any questions in the past, but we expect that in the future they will ask few more questions, right? I may have skipped, I may have not seen all the past paper questions. Right, now you can see in the past papers you can see number format exception. Today we got that exception few times when we were working with wrapper classes, right? Let's see whether there are any things that we can do from today's one. Let's see. Those object oriented questions. All object oriented. No, nothing in last year. I think I highlighted few. This one. So this is enumeration question. Consider the following. So this is 2018. Consider the following code written in Java. Enum color. Now we can say it's enumeration. Color. The possible values are red, green, and blue. Right? Red, green, and blue. There's a class called ex9 where you are creating a. So that is not a very good example anyway. They are not creating any object. They are just trying to explain, use the concept called enumeration only. So you can see it's a type is now enumeration. Type is now enumeration. C1 and it's keep straight away assigning color red, because if it is a color you can't assign anything. You have to assign either color red, color green, or color blue. Right? There's a type safety because this variable is of type color. Now if you print this C1, what is going to happen? It is going to print red, right? Because you have assigned color red. If you are printing C1, it is going to print red. So the answer must be C. Okay. Right. So let's see whether there are any other questions. Yeah, so this one. Select from among the following the valid options to which ampersand deprecated annotation can be applied. So they ask for what kind of things this can be applied. So you know that deprecated means that method is deprecated. In the future we may remove it, right? So that means it is applicable to what? Methods. It is not applicable to variables, operators, arrays, or identifiers. It is applicable to methods. Okay, so the answer is A. Anyway, I have the answers with me. Therefore, I am not showing you the answers. The answer is A. Okay. Right. This is another one. It's something to do with the string. So we have main method string. The reference variable is obj. Whatever I like Java, that means I like Java in once without spaces. Then they ask what is they are now system print in the length. So that is a very straightforward question. What is the length is 1 2 3 4 5 6 7 8 9. So the answer is 9. Okay, so those are very simple questions. So there's another question. Now it says there's a string called s1, right? Hello. Then you can see s1 dot replace l with w. Now remember strings are immutable, so therefore they are assigning it to a different string now. Still s1 is hello, but now s2 is going to be replacing all the simple levels with w. So what they are printing is s2. Therefore it is going to see the effect. But if they are printing s1, no, s1 is still hello, right? But the s2 is a new reference variable we are assigning. Therefore it is going to have in these two places it is going to have w. So the answer is HEWWO. So the answer is this one. Okay, right? So here they are assigning it to a different variable. That is fine, right? But in the if another question if they say system out println s1, definitely still hello. Okay, so you can run it and see by yourself. So let's see whether we have few more. I may have missed some of the questions which are using those concepts. Okay. Right, so this is another one. Again, the same thing, the deprecated annotation. Right. So it indicates that the mark element should no longer be used. Right. It informs the compiler that the elements is mean to overwrite. No, for that we have the ampersand override. So this is definitely wrong because that is all about the override annotation. It tells the compiler to suppress the specific warnings. No, for that we have the suppress warning annotation, built-in annotation. It is mentioned in your book or the note that I am going to upload to the Google class. It asserts that the code does not perform potentially unsafe operations on its vargs. No, that is something wrong. That is not related to deprecated. It specifies how the marked annotation is stored. No. So those things are used in database programming, right? How the annotation is going to be stored, etc. But it is what it's marked that element should no longer be used, right? It's actually it's not a forcefully. We want that you better not to use it, because in the future we will be removing it. So therefore, the closest answer is A. Right? Closest answer is A. Right? So this is another one. So this is a string hello, and they are printing index of fee. So that is fine because they are printing it, right? str index of a. So what is the index of fee? Index is 0 1. So the answer is A. So don't expect this kind of paper right now, because now the new syllabus is there. The things are getting tougher, right? Right. So this is another example. I think yeah, that is also for string. So first they are asking you the length. So you have to find the length of this string, including the space. Then they are talking about the name to child 5. So what is the fifth character? So that you can do. Again, this is index of and last index of O, right? So what is the index of O? That is the first occurrence. The last index means where you have the last O, that is this place. So those numbers you have to get it, and that is concatenated by space. Okay, so those things you can do now. Select from among the following the valid annotation used in Java. So the valid annotations that we have mentioned are override, deprecated. Okay, it's very easy because these are just keywords, right? These are just keywords. Okay, so that's it for the last 4 papers. Right, so we covered quite a lot. We covered the wrapper classes, we covered the annotations, we covered the enumerations, right? What is the other one? Even I can't remember now. Annotations, wrapper classes, yeah, string handling, right? All right, so if you have any questions, you can just ask those in the WhatsApp group. It's close to about 3 hours, so we are going to stop at this point. Okay, right? Thank you.